Welcome back, friends. We have been solving CSIR problems and this is one of the questions asked in June 2011. Consider the function f of x is equal to e power minus x and its Taylor approximation g of x of degree 3. For x is equal to 1 by 3, g of x is. We are given four options: positive and less than 1, negative and less than minus 2, positive and greater than 1. Fourth option, less than 1 but greater than 0.75. Given the context, we are given that function is f of e power minus x. F of x is equal to e power minus x. And we all know that e power minus x can never be negative. It can, the least value that it can take is, it may tend to 0. So, given the context, this option has no relevance to our question at all. So, negative and less than minus 2 is, option is false. So, this option has no relevance to this. And we are given that f of x is equal to e power minus x and g of x is a Taylor series approximation. But we are not given about what point this is to be expanded. So, what do we do is, since f of x is equal to e power minus x, which is continuously differentiable, at every point, in fact, it is continuously differentiable. So what do we do is, we take it for granted that it is differentiable at the origin also. Now we know from the, if any function is continuously differentiable at x is equal to a, that can be expanded as a Taylor series in the interval x minus a x plus a, in the open interval x minus a x plus a as an infinite series. So this you can write it as a, this is the Taylor series expansion. F of x is equal to summation over n is equal to 0 to infinity, where fn of a is the derivative, nth derivative of f at the point x is equal to a by over n factorial times x minus a power n. So if any function is infinitely differentiable, continuously differentiable at x is equal to a, then it can be expanded as, or it can be approximated as a infinite Taylor series expansion. Now we make use of that idea. So this is, since e power minus x is infinitely differentiable and we are asked to consider only approximation up to third degree. So we take it for granted that the function is expanded around the origin or about the origin, and we consider only degree 3 terms. So 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial, and we take this to be g of x. So from that, now what do we do is, when you substitute x is equal to, when x is equal to 1 by 3, when x is equal to 1 by 3, what happens? 1 minus 1 by 3 plus, when you substitute you have 1 by 3 whole square, 1 by 9 over 2, see 1 over 18 minus, this is 1 by 3 factorial, 1 by 3 factorial is 6, 1 over 6 times 1 over 27. Now when you simplify this, this is 2 by 3 and this becomes, this is 2 by 3, this is 2 by 3 plus 1 over 9, when you simplify this, 8 minus 1 over 18, 9 minus 1 over 18. So that is equal to 2 by 3 plus 1 over 9 times 4 by 18. When you cancel it out, you will get this. 8 is cancelled with this. So this is 2 over 3 plus 4 over 81. So this is greater than, in fact this is less than 0.75. This value is less than 0.75. On calculation you can see that this is less than 0.75. Therefore this option is wrong. This is option 4 is wrong. And it is obviously this is less than 1 also. This value is less than 1. So less than 1 and positive. Therefore option 2 is wrong. So what we are left with is option 1 is wrong. So this is one approximation of e power minus x. There can be several approximations because depending upon the degree, number of terms that you take into account, the approximation, the value of e power minus x changes. So, but why we have considered up to 3 is we are given that g of x is of degree 3. So up to that point we have considered, and we have taken for granted that e power minus x is expanded around the origin, about the origin, because we are not given about which point it is to be expanded, we are not given. So we have we took it for granted that it is expanded about the origin. Okay.